This conference will now be recorded.
Very good evening, students. We have been discussing POIQs from JEE Mains paper. We had already discussed few questions from the paper 6th September 2020, and this is the question paper. From where I'm getting the questions are from the sheet 2. Okay, so let us start our discussions. The question says, in the figure shown, so this is the figure, you can see that in the figure shown, the current in the 10-volt battery is close to 0.36 ampere from negative to positive terminal, or 0.42 ampere from positive to negative terminal, or 0.71 ampere from positive to negative terminal. Positive to negative terminal means if I say this is P, this is Q, so current is flowing from P to Q. This is positive to negative terminal. Or here the last option says whether it is 0.1 ampere from positive terminal to negative terminal. Okay, so this is the question. This is the current which is flowing through the battery 10 volt. So this is what you have to solve for. So you look, this question can be solved in many ways, but very simple way to solve this problem is to use the KVL. Okay, before using KVL we have to define the loop, okay, and current in the respective loops. Okay, let me take the current I1 which is flowing out from the battery 20 volt. Okay, so this is how it goes. It goes all the way up to here. Okay, I1, and let us say a current I2 which is flowing in this loop. Okay, so current I1 is flowing in this loop. Okay, and I'm taking another loop where the current I2 is flowing. Okay, so basically I'm taking current I2 which is flowing through the battery 10. So this is, see, this is my loop 1 and this is my loop 2. Okay, and you know this is the total current. Suppose it is I1, now it is divided into two parts, right? So through this 10 ohm resistance the current will be I1 minus I2. So this we can find out using KCL, right? So by using KCL we get current through this to be I1 minus I2, okay, through the 10 ohm resistance. Now this is okay, so this is the thing. Now what we have to do, we have to apply KVL. Applying KVL for L1. Let us write that. Okay, so look here, current I1 is all the way going from this battery to this resistor 5 ohm. Let me write this one. Then see, it is going through, see, I1 minus I2 is going or passing through 10 ohm resistance, I1 minus I2. Then through this how much is flowing? So through this just I1 is flowing out. Okay, so through 2 ohm resistance, just I1 is passing. Okay, so this will be equal to the battery voltage of the battery. Now if we simplify a little bit, then what we get, 5 plus 10 plus 2 whole into I1 minus 10 I2, which is equal to 20. Okay, so now for that we'll be simplifying. So this is 17 I1 minus 10 I2 is equal to 20. Let us give this equation in number. Let us check. This is equation number 1. Okay, now we have the other loop. Okay, let us write the equation or apply the KVL for the equation loop 2 also. Okay, now applying KVL for loop L2. So this is L2. You look, this current is flowing. See, I2 is flowing through the resistor 4 ohm, and then this is actually, I'm just going in the opposite direction of this current I1 minus I2. So I'll take here minus 10 into I1 minus I2, and this is equal to the battery voltage. See, battery voltage, I am going from this to this, so obviously I should take this as minus 10 volt. Okay, minus 10. All right, so look here, this from here, let me do one thing. Let me simplify further here. So as you see here, it will be minus 10 I1 plus 14 I2 is equal to minus 10. Okay, further, if I find the value of I1 in terms of I2, because I have to replace this I1 here so that I get I2. I could replace I2 by I1, but I have to find out anyway. I have to find out the current I2. So that's why I'm just replacing I1 in terms of I2. So what we get here, look, if I take this to that side, I'll take 10 this side, minus 10 this side, so I'll get ultimately, see, 14 I2 plus 10 divided by 10. Okay, divided by 10. All right, let us go to the next page. So see, this I1 will be, if we just simplify a little bit, or let us write directly this one. This is, see, 14 I2 plus 10 divided by 10. So this is I1. This, let us say, this is equation number 2, and this I1 will be substituting in this equation 1. So equation 1, let me write it here once again. So the equation 1 is 17 I1 minus 10 I2 minus 10 I2 is equal to 20. This is what the equation 1 is. Now if I replace this I1, taking the value from equation 2 in this equation, now this is this, okay, minus 10 into I2 is equal to 20. Okay, I'm just taking the value of I1 from 2 and then replace like putting it here in the equation 1. Okay, so we can make this smaller, or otherwise let me just multiply the 10 with 10 everywhere. So where, see this, I'll get like this plus 170, and here I'll get 100 I2, and here I'll get 200, right? Now look, this I'll take it to there, and here see 17 and 14, sorry, yeah, 14, it will be this. Okay, 238 minus 100 whole into I2, and this will be, see, 200 minus 170, that means 30 only. This will be 30, 30, right? So this will be I2 is equal to, see, 30 divided by 138. This is in ampere unit. So look, if you do this division, okay, so you have to go with 2, right? And then 2 point, I'm sorry, this is 8. Okay, sorry. So we have to go with this, so you will get 6, and this will be 76. This is 4, 2, so this is what, now you'll get 0 here. So if you multiply 2, it will be more than this, so I'll take 1, 2, so you have to go for further greater one, so some, so you have to go, I think, with, there is a, okay, so you can go up to 7, okay, 217 kind of that you are getting. So it is approximately, if I go with second decimal itself, so you'll get nearly 0.21 ampere. Okay, and see how it is flowing. It is flowing from P, and this is Q, so it is flowing from this. Okay, I have taken the direction of the current I2 to be P to Q, so it is flowing from positive terminal to negative terminal. So look, this fourth option is going to be correct for this question. Okay, so this is how you can do it. If you do this way, calculation is little bit lengthy, but it will be definitely correct answer. Okay, it will give you definitely correct answer. All right, we'll go to the next problem. So this problem says a charged particle going around in a circle can be considered to be a current loop. That is fine, because we have seen in case of atomic magnetism also, right? Say if a charged particle, say here charged particle is positive charged particle, let us say. So if it is moving like this in a circular path, okay, then then there will be current flowing in the same direction. Okay, that means in the anti-clockwise direction, there will be a current flowing in this. Okay, all right, so the charge, say positive charge is moving, so it can be taken as in a circular path. So this circular path can be taken as a current loop, where the current is flowing in the same direction of the motion of the charged particle. Okay, since it is a positive charged particle. Now the question is, a particle of mass m A particle of mass m and charge q is moving in a plane with the speed v under the influence of magnetic field b. A charge particle going around a circle can be considered as current loop. This is general statement. A particle of mass m, see particle mass m and charge q is moving in a plane. So this is the plane. You can take this plane as the plane of the paper. Okay, plane of the paper, or this is in the horizontal plane, suppose. Okay, horizontal plane like this. So this horizontal plane, and it is moving with the speed v. It is said moving with speed v. So v is the linear speed, and that will be always along the tangent. Okay, so this will be along the tangent. Okay, and it is moving in under the influence of magnetic field b. See, if I take this charge particle to move in this direction, so centripetal force has to be in this direction. Okay, so centripetal force is actually supplied by the magnetic force that is acting on this charge particle, and that is, this is q is equal to v cross b. Okay, so this is central force. This is actually fb. Okay, this should be fb. So if this fb has to be in this direction, look, your magnetic field must be perpendicular to this lobe, and it has to be going into the plane of the paper. Okay, it has to be going into the plane of the paper. That means, the magnetic field is this here, and let us take that magnetic field to be uniform throughout the loop. Okay, like this is the magnetic field. The magnetic moment of this moving particle, you have to find out magnetic moment. Magnetic moment is a vector quantity that can be written as I into a. This is one way to write, and another. Okay, so this is one way to write. This a has to be taken as the area vector. Okay, let us first find out the magnitude of this. So what is I? I is the current, right? So current, here you have to find out the charge divided by time period of revolution. So time period of revolution is how much? If the v is the linear speed, then you get 2 pi r by v. This is the time period of revolution. If the radius of the circular path to be small r, so you get qv by 2 pi and small r. R is the radius of the circular path. Okay, so I have got the current. Now this area magnitude of the area will be pi r square simply. But if I multiply this to what I am getting, magnetic moment, I am getting q v by 2 pi small r into pi r square. This is what I am getting. So this time period 2 pi r by v, Okay, let me keep this current to be like this. So I we have got QV by 2 pi r. Now look, in this expression, neither I have r, neither nor I have q. So I have to replace that q and r somehow by b and v and m. So for that, we have to see area also. Let me write it here itself, pi r square. Okay. So m will be qv by 2 c pi and 1 r will be, so qvr by 2, kind of this. Okay, but I have to replace this q. So here you can do one thing. So q, v and b, maximum force, maximum magnetic force, qvb is equal to mv square by r. You can do that. So if you do that, from here you will get q is equal to mv by r into b. Now let us put it here. Okay, then q v by 2, sorry, vr by 2, vr by 2 into q, that is mv by rb. So this r will cancel each other. So what I get, this m to be equal to, okay, so this is actually mv square by 2b. Okay, now look the direction. See in the options, this is given in terms of the direction of magnetic field. Okay, magnetic field is in the downward direction, but you know how to find out the direction of the magnetic moment. You have to get it by using thumb rule. So if you stretch your fingers, or if you try to hold the or grab the current loop by your 4 fingers of the right hand, then your thumb must be going in this direction. Okay, according to this figure. Okay, so thumb will be going in this direction, so magnetic moment will be opposite to the direction of the magnetic field. Okay, so then what I can write, you look here, if I have to write in terms of vector, then I can write like this, mv square by 2b, mv square by 2b minus b cap. Now in the option it is given in terms of vector, then what I can write in terms of vector, so minus, let us keep it here, then I'll write mv square by 2b square. That means I'm just multiplying b, magnitude of magnetic field, in the numerator and denominator. So then you will get actually mv square by 2b square with a vector sign of b. So this is actually the magnetic moment. I hope you have understood this. Look, the option B will be the correct answer for this question. mv square b by 2b square. Okay, look this with a minus sign. So option B will be the correct answer for this question. Okay, now let us try to solve the third question. So the third question says, a square loop of side 2A carrying current I is kept in xz plane. You can see that this is a square loop of side A which is kept in the xz plane. So this is z axis, this is x axis. So This is in the horizontal plane or in the XZ plane. You can see that a long wire carrying the same current. So this is carrying current I, and the wire, this is a long wire which is also carrying current I, is placed parallel to Z axis. It is placed parallel to Z axis. You can see that. So this is in lying in the plane, and this is just top of that. Okay, just top of that. See kind of this. So you can see this figure itself is a very good representative figure. So this is in the horizontal plane, and this is just top of that in the y-axis. Okay, it is just crossing the y-axis, but it is parallel to the XZ plane itself, like z-axis, parallel to z-axis. And this coordinate of this is, this is 0, b, and 0. Okay, that means the distance from the plane to this wire. See, if I draw this, suppose this is the plane and the wire is this much distance. Okay, what is the distance? This distance is b. This is what it is said here. Okay, now what you have to find out, the magnitude of the torque on the loop about the z-axis. So z-axis is this only, so torque I have to find out. So the torque is actually tau is m cross b, the magnetic moment cross the magnetic field. So what is the magnetic moment? You look, the current is flowing in this way, so the magnetic moment will be in the upward direction or along the y direction. Okay, magnetic moment is what? Magnetic moment is actually I into area. So I into area is the area of this square, which is 4a square, and this is along y direction. Okay, and then b, see, I have to find out the magnetic field. See here, this condition is given. That means the magnetic field which is produced by this long wire around this loop is uniform everywhere. Okay, like this, uniform. Okay, the uniform magnetic field is produced, but I have to know the direction also. In this case, since it is, so it will be, magnetic field will be like this. Okay, like this, magnetic field will be, okay, due to this wire. All right, so this will be actually at this plane, at the about, see, at this plane it will be along positive x direction. Okay, at this position it will be along positive x direction. So what is b? B is actually, see, if I write in terms of vector itself, see, I know for a long wire mu0 I by 2 pi b. Here r is b, so 2 pi b, and this is along x direction. Okay, x direction. Anyway, I have to find out the magnitude. I can find out here now, taking the cross product. Okay, cross product, if I just get the magnitude, so I have to just multiply the magnitude. So I have to multiply the magnitudes. Let me multiply and see. See, torque is 4a square into mu0 I by, oh, I see here there will be I also. So mu0 I by 2 pi b. Okay, that means, if I just this 4 I can strike out. Okay, so I'll get 2 mu0 I square a square. Look, I'll just strike this, and this 2 also from here. So 2 mu0 I square a square by pi b. So 2 mu0 I square, I'm sorry, 2 mu0 I square a square by pi b. So option 1 will be the correct answer in this case. Okay, option 1 will be the correct answer for this question. Okay, all right, so this is question 3. Let us go to another question. Okay, so this is from ray optics. This question says a double convex lens has power P. Double convex lens means, sorry, I'm sorry. So this is double convex lens. Okay, nearly convex. I hope you are understanding. So okay, so this is the double convex lens. That means both side will be convex, and see both side will have, see this is a part of sphere and this is part of another sphere, obviously you know that. Okay, so you will have radius of curvature, let us say this is r1, and radius of curvature for the other one to be this will be, center will be here somewhere. Okay, for the other side this is minus r2. Okay, with sign convention, right? And here see the question is a double convex lens has power P and same radii of curvature. Both r1 and r2 are same by magnitude, that is r of both surfaces. The radius of curvature of a surface of plano convex lens made of the same material with power this, that is with power 1.5 p is how much? See, this problem can be solved very easily. See, with the same kind of formula you will be given sometime. So this is now, so given, see the power is given. Okay, power means you know 1 by f, and 1 by f we know according to lens makers formula, we know the refractive index of the material here. See, since it is not dipped into some material or somewhere, it is, I'm taking in the air medium, so refractive index, I'm just writing the lens makers formula, refractive index of the lens material minus refractive index of the medium, that is air here, by the refractive index of the medium whole into 1 by r1 minus 1 by r2. So this is what we know. Okay, so look then what we are getting, this power is given, right? Power is then mu minus 1, and this is, see here I'll write in place of r1 I'll write r, and minus sign is there, and in place of r2 I'll write minus r. Okay, so then it will be r, see 1 by r itself. Okay, so you get, you know, p is equal to 2 into mu minus 1 divided by r. Now if I make it to half, okay, if I make it to half, that means if I make plano convex lens out of it, so let me take this plano convex. Okay, so this side has radius of curvature infinity, so now r2 is infinity and r1 has certain value r, say, okay, certain value r as it was having. Okay, so now see the lens, this, okay, I have to find out the radius of curvature only. Okay, so let us take that as r. Okay, so here the power is given, in this case also the power is given as 1.5 p, which is actually 1 by f prime, is equal to, see now I can write same, this one is same, but here there will be a change, so 1 by r1 will be 1 by r, and this is 1 by infinity, so infinity is 0, so you will get, you know, mu minus 1 by r. Okay, you will get this mu minus 1 by r. Now from here if I just okay, I have to find out, what I have to find out, what is r. Okay, so let me, I'm sorry, the radius of curvature of the surface, the plane, okay, same material with power. I hope it will be not radius, it will be the radius of the curvature of the planar convex lens. This is a material. P is here, actually this is not radius, refractive index of the, okay, this will be refractive index, refractive index, ri, r dot I, refractive index. Okay, so I think there is some typos here. So if I now put the values of this mu minus 1 by r, this part, see this I can write as p by 2, right? I see. Then what we are going to get? Okay, let us see here. Let us take this as r prime. Then things will be same. I think it will be the question. Okay, then it will be the question. Okay, radius of curvature. Okay, okay. So let us take this as r prime. Okay, so then we can just replace this. This is r anyway. This is r prime. So I'm just putting the value of this mu minus 1, which is pr by 2. Okay, now things will be all right, I guess. So material has the same refractive index, that is fine. Mu minus, okay, I have r prime here, r prime. Okay, so pp I can strike out. I have to find out r prime. So r prime is equal to r by 1.5 into 2. Oh, so much confusion. Anyway, I think yeah. So this is the answer. Okay, r prime is equal to r by 3. So you are getting r prime is equal to r by 3. Okay, I will not confuse you again. Let me tell you. The question was that there is a double convex lens for which the power was given, and you had been asked to find out the radius of curvature of the same material with which the lens was, double convex lens was prepared. Now the lens is plano convex lens which has different radius of curvature r prime, so that you had to find out. Okay, so radius of curvature of that convex plano convex lens has to be found out. Okay, so that is r by 3. So this is the answer. Okay, so sometimes this type of, with this concept itself, with this lens makers formula itself, you will be asked to find out. Say you will be given, same plano convex lens, sorry, double convex lens. Now you just cut it to half. So each half will be how much focal length. Okay, kind of that question will be there. Okay, so you can see from here itself, see focal length will be actually half. Okay, focal length will be actually half. I'm sorry, here. Okay, let me tell you this itself. See here, when I have, see both r1 and r2 are r is equal to r. See what is the thing we are getting? We are getting 2 mu minus 1 by r, right? Okay, now what is f? F is r by 2 into mu minus 1. Okay, so in the other case, what we have got, just for plano convex lens, if you just make it to half like this, about its uh, about the axis which is perpendicular to the principal axis, then this 1 by f we have seen, it will be mu minus 1 by r. Okay, or from here we are getting f is equal to r by mu minus 1. Okay, so eventually you look here, we are getting, actually this is let us say this is r prime, sorry, f prime. Okay, f prime is actually becoming 2 into f. Look, so this has, if this has focal length f, with the same length, if you just make it to half, just cut into half, okay, then you know this part will have 2f focal length. Okay, so this kind of question also being asked in questions. Okay, all right, now we'll take up one more question. Okay, so the question is very simple. We have been discussing these questions, this type of question again and again. This is from electromagnetic wave. So question number 5 said, I'm not writing the whole story here or whole the questions. I'm just speaking the questions and writing the equations, respective equations here. For a plane electromagnetic wave, the magnetic field at a point x and time t is given. See, at any point for a plane electromagnetic wave at any point x and any time t, the magnetic field is given like this. 1.2 into 10 to the power minus 7 sine of 0.5 into 10 to the power 3 x plus 1.5 into 10 to the power 11 into t bracket close. So this is sine omega t plus kx, kind of that. Okay, omega t plus kx, and this is moving along. So this is having Tesla unit and moving along positive k direction. So the whole wave is actually, see, this b is oscillating in the positive k direction, and this is in Tesla unit. So you know what? So you have to find out, see, the instantaneous electric field E and corresponding magnetic field. The instantaneous electric field E corresponding to this, that means you have to find out corresponding to this magnetic field. You have to find out the expression for ET. Okay. So I'm not giving the options here just to save the time. Let us try to solve it. So you have to, how do you write from here? From this information itself, how do you write the electric field, instantaneous electric field? You know, for that you need to know what is E0. You know, this expression has to be written like this: E0 is equal to E0, then E0 is the amplitude, then sine this whole term, there is no change. Okay, we don't have to change anything here inside. Okay, into t, but this direction we don't know, that we have to find out. Okay, we have to find out the direction, and this will be volt per meter. So only thing you have to find out this one and the direction. That's it. So what is the magnitude of this magnetic field here? This is given 1.2 into 10 to the power minus 7. So how do you write this? So we know this, the magnitude of the electric field and magnetic field, they have a unique relationship, that is E0 by C is equal to B0. Okay, so you know E0 will be CB0. So this is the relation. Now you have to multiply this. So to get E0, you have to multiply this B0, that is the magnitude of the magnetic field, 1.2 into 10 to the power minus 10 Tesla, with C, that is 3 into 10 to the power 8 meter per second. This is the speed of light in vacuum. So look what we get. We get 3.6, and see here 110 will be there, so it will be 36. So amplitude of the electric field or magnitude of the electric field is obtained as 36 volt per meter. Now it is easy to write. See, I have got E0 is equal to 36. So I hope you have understood this. This is the lesson you have to remember. E0 by C is equal to V0. So from there, I could find out the magnitude, and rest of the things, as I said, will be equal except the direction of oscillation of the electric field vector. So I'll write this here. So direction, let us find out first. See here, from this, from this argument, you have to find out. See, this B vector is actually, or the magnetic field vector is oscillating in the Z direction. This we know. Okay, it is oscillating in the Z direction. And what more we know, see here, when we write equation, generally we write B vector is equal to B0 sine of omega t minus kx. So this is the standard form. If this would have been there, then I say that the total wave or the electromagnetic wave is actually traveling in the positive x direction. When I have positive here, I'll say that this is, see, the total wave, EM wave, is traveling along negative x direction. Okay, negative x direction. If that is the case, now again we know one more thing, the direction of the total wave, that is the propagation vector, will be given by E cross B. Okay, this is actually just to get the direction. This formula is fine, otherwise there is some term here. So E cross B. Okay, K, this is the direction of the propagation of the electromagnetic wave that we will be able to find out by taking cross product of E and B. See, now I'll just go for, see, K propagation vector, which I know to be minus I cap. Okay, now K, so B we know B is along positive k cap direction. So K is this is Z cap, let us say. Let us write this as minus X cap, this to be minus Z cap, sorry, plus Z cap. Now I know cyclic rule, see, X cap, Y cap, Z cap, and Z cap, like this. So it goes like this. Okay, if you take the cross product of X cross Y, you will get Z. If you go in other way, you will get minus. Okay, so here I have to get minus X cap. Okay, minus X cap. So this is E cross B. So how do you get minus X cap when I know this is K or this is Z cap? Okay, when I know this is Z cap, I have to get minus. So Z, so you have to go in this way. If you go Z to X, you will get plus Y, or Y to Z. If you get, you will, like, you go, if you take Y cap cross Z cap, you will get positive X cap. Okay, if you write Z cap cross Y cap, then you get minus I cap. So electric field will be oscillating, I'm sorry, this is Z, right? So this is Z E cross B. I have to get minus. Okay, yes, so Y cross Z will be positive. Let me check once again. Yes, minus sign is there. That is fine. Okay, so the options are, yeah, I think in the option there is one thing here. Look, I can just write this. Okay, so if I write this, to get this, this, I have to write here -1, minus. Okay, minus. So there is an option here which is, look, this one, E is equal to minus 36 sine omega t. So like sine this part, j cap. Okay, yeah, this is obvious. If you have a minus sign over here, then only you will be able to get this. Okay, so it will be actually along negative y direction, so that you get minus x here. Okay, so this would be actually correct option. So there were other options also. Other options means other option with k cap with positive and j cap with positive sign over here. So these are the options. So this option will be the correct answer for this case. Okay, since we are not getting directly from here, okay, so I have to give like this. Okay, so yeah, so y cross z, we are getting y cross z. So to get minus, we have to actually write minus I cap cross z cap, which is giving you minus x cap. Okay, so this is the answer. All right, so this is how you have to find out the magnitude, and rest of the things you will just go as it is. Only thing you have to consider the direction. So that direction can be found out from, see, just by seeing the argument whether x, coefficient of x, is positive or negative. You can understand the total wave, how, in which direction it is flowing, so, or propagating in this case. Since it is positive coefficient, so we say this is traveling in negative x direction. Okay, then while finding out the direction, this k, propagation vector, is equal to E cross B. So one among them will be given. You have to find out the direction of the other one from the cyclic rule. Okay, so this is all for today. We'll take up the remaining problems in the next class. Thank you for your patience. Bye for today.